Hello friends, welcome to my channel. So today we are going to solve this maxima and minima question. So let's read the question. Which one of the following graphs describes the function fx equal to e to the power minus x square plus x plus 1? So this function represent which graph that we need to find out. So here some four graphs are there. We can see the options. So here we can see some ups and downs are there in the graph. So we can assume that by seeing this option that we can solve this through maxima and minima concept, because some maxima and minima points are there we can see in the options. So before solve the question, let's read some proper notes. So maxima and minima of a function are the largest and smallest value of the function respectively, either within a given range or on the entire domain. The maxima and minima we find out. So collectively, they are also known as extrema of the function. So maxima and minima collectively known as extrema of the function. So real life application we know in economics, business and engineering, these maxima and minima are used. So here we can see one graph is there. So this is y direction, this is x direction, this is the graph. So here we can see one point is there, that is local maxima. It is represented as local maxima because in between this and this point is the maximum value. So this is a local maxima, not in the whole graph. This is not the maxima in the whole graph. There can be this point can be the maxima, or some other value, other maximum point can be there. If the graph is there can be the maximum point. So in between this and this point we can tell this is the local maximum. Again, in between this and this point, this is the local minima. Again, in between this and this point, this is the local maximum. So let's read some important points. Maxima and minima for function of one independent variable. So here we have written y equal to fx. X is the independent variable, so here only one independent variable. So for this type of function, we can find out the maxima or minima by following these steps. So let's read the steps. Step 1. First of all, we need to find out the first order derivative dy by dx, and that we need to equal with 0. So then the result we will get some x value, and that are the stationary points. It can be one or many, so it will be called stationary point. Let's say x equal to 1, x equal to a, we have calculated. So in the step 2 we will find out d2y by dx square, and then we can tell a function fx has maxima at x equal to a if f dash a equal to 0 and f double dash a less than 0. So here a is the stationary point we have calculated, and f dash a equal to 0, obviously, because we have calculated means we have find out the by this calculation by equating this equation with 0. So obviously f dash a equal to 0, and f double dash a, if we get less than 0, then we can tell at x equal to a we will get the maxima. And in the reverse case, like a function fx has a minima at x equal to a if f dash a equal to 0 and f double dash a greater than 0. Now one more point is there. A function fx has no maxima and minima at x equal to a if f dash a equal to 0 and f double dash a equal to 0. So it is not greater or less than 0, it is equal to 0. Then we can not say that it is a maxima or minima. So this type of points, like this point x equal to a, for that there is no maxima and minima, this type of points are called saddle point. Okay. Now one more important concept is there. To find maxima and minima of a function of two independent variables. So here x and y, there are two independent variables. For this type of function, how to find out the maxima and minima. So there are also some steps are there. So step 1, just same, we need to find out del f by del x and del f by del y, and that we need to equal with 0, and the solution will be the stationary points. So in the step 3 we will find out the del square f by del x square, that is the double order derivative of this term. So we will find out the r like that, and next we will find out the s like that, del square f by del x del y, and next t we will find out del square f by del y square. Now in the step 4, if rt minus s square greater than 0, then and r less than 0, the stationary point will be minima, and rt minus s square greater than 0 and r greater than 0, then the point will be maxima. Then rt minus s square equal to 0, so for that we cannot say that it is maxima or minima, or it is not maxima minima. So to get a conclusion we need further investigation or calculation. So here rt minus s square less than 0, so if it is less than 0, then we can directly tell it is neither maxima or minima. Now let's solve the question, try to solve the question. So we will copy the function from the question. This is the function given in the question. We will copy this and we will paste here. Now here we can see here is only one independent variable, and that is x. So we will follow these steps, this step 1, step 2. So first of all we will find out the differentiation with respect to x. Okay, we can write dx. So in the right hand side also, d by dx e to the power minus x square plus x plus 1. So we know how to derivative this. So first e to the power minus x we are keeping as it is, we are doing the derivative here, 2x plus 1. So now this e to the power minus x we are doing and keeping this as it is. So now in the step 1 it is written to get the stationary point equal to 0. We are doing now e to the power minus x, 2x plus 1 plus minus e to the power minus x square plus x plus 1 equal to 0. Now 2x e to the power minus x plus e to the power minus x plus not plus, here we will write minus x square e to the power minus x e to the power minus x minus e to the power minus x equal to 0. Now here we can see we can cut this plus minus, and here x e to the power minus x square e to the power minus x equal to 0. X e to the power minus x equal to x square. Okay, no need to go there. So here we can do common x also, one second, sorry, here we can do common this e to the power minus x equal to 0. So from here we can write x equal to 0 or x equal to 1. So what I was telling, we can directly means divide it here, and we can remove this, or we can do like that, e to the power minus x equal to 0, and which is e to the power minus infinity, and x equal to infinite will get. So that we can do, but I think no need to do that. So we can proceed with this and this value only, because our graph, if you see here, we don't know at x equal to infinite we not able to see what is the condition of our graph. So it seems it will be 0 at x equal to infinite, but for all the graph that is same. So we can neglect this part, because at x equal to infinite we can't analyze here, or for all the graph it is same. So we are neglecting this, just taking these two stationary points and analyzing our further things. So for x equal to 0, at x equal to 0, we will find out f double dash x. So first we will find out f double dash x, which will be d by dx, and here the result what we got, that is e to the power minus x 2x plus 1 plus this okay. Hope it is understandable. So here we have written the f dash value, and that we are doing derivative again with respect to x. So let's derivative e to the power minus x we are taking as it is. Now here 2 we are getting, now this we can take as it is. Now minus e to the power minus x, again here we can take it as it is, and here 2x plus 1, and plus here we can take it as it is, and here we can e to the power minus 6 if we derivative. Now again if we write here 2 e to the power minus 6 plus not plus, it will be minus 2x e to the power minus 6 minus e to the power minus 6 minus 2x e to the power minus 6 minus e to the power minus 6 plus e to the power minus x, here x square e to the power minus x plus x e to the power minus x plus e to the power minus x. So this we can cut, and here what are there, like we can write e to the power minus x with these two. Then here one term is there, this and this. With these three we can write minus 3x e to the power minus x plus x square e to the power minus x. So we got the f double dash x value. Now we will equate, not equate, we will find out at x equal to 0. At x equal to 0 it will be 1 minus 0 plus 0, so it will be 1 greater than 0. So at x equal to 0 stationary point we will get local minima point. Okay, because here we have written the condition. Hope you are able to relate. If f double dash take less than 0, then it is greater than 0, as we are getting 1, so it will be minima. Now another here stationary point is there, this x equal to a. Now at x equal to 1, now at x equal to 1, f double dash 1 will be, so this is f double dash x, so in place of x we will place 1 e to the power minus 1 minus 3 into 1 e to the power minus 1 plus 1 square into e to the power minus 1 e to the power minus 1 minus 3 e to the power minus 1 plus e to the power minus 1. So it will be minus e to the power minus 1. So here e to the power minus 1 is greater than 0. So this term, this whole term is less than 0. So at x equal to 1 we can tell we will get the local maxima. Okay, so here we can see, if we see the graphs properly, so this is going infinite, so we don't know what will happen with the graph in the infinite, at x equal to infinite, but we can tell in somewhat this point it is 1, so somewhat in this place it will be 1, somewhat in this place it is x value will be 1 and x value will be 1 here. So in these graphs, if we check at x equal to 1, only here we are getting the maxima. So we can tell that this option is the right answer, because here the question it was asked, which one of the following graphs describe the function fx this. So we, after analyzing this function, we got the maxima at x equal to 1, local maxima, so that only satisfying these graphs. That's why the correct answer is option B. Hope you got the answer. If you like the video, please like and subscribe, and if you have any doubt, please comment. And thank you for listening me.